Right, I've been asked about thinking distance and braking distance and stopping distance, and just want to quickly go through how you can work things out using it. So we did this when we were back in school, and we said that stopping distance, that's the total distance it takes you to stop in from the point where you're driving along. You see the thing you need to stop for, you see the hazard, you think, right, I've got to start braking, I've got to put my foot onto the brake pedal, start pushing down on the brake pedal, and then the brakes actually need to work and stop the car. So the stopping distance is made up of two different distances. The thinking distance is the distance the car travels in the time it takes the driver to react. So from the point when the driver sees the hazard to the point where the driver starts to press down on the brake pedal. And the braking distance, that's the distance the car travels in from the moment when the brakes start to be pressed to the point where the car has actually reached a stop. And the whole kind of mechanism by which car brakes work is they take the kinetic energy of the car and they turn it into heat, into thermal energy. And they do that by applying a braking force. And the brakes are attached to the wheels, or more precisely, you've got the brake pads pressing down on the brake discs, which are attached to the wheels. And as the car slows down, the brakes get hotter and hotter. So in terms of kind of the maths of it and the equations, initially you have the kinetic energy of the car, which is half times mass times speed squared. Remember, mass must always be in kilograms, and that's going to be equal to the work done by the brakes. Work done is force times distance. So force is the amount of newtons that the brakes are pushing on the wheels with, and D, the distance here, that is going to be the braking distance, how far the car travels. If you've got a car with mass 1,500 kilograms, so look at a question travelling at 10 meters per second, the driver applies a force, a braking force of 10,000 newtons. How far does the car travel before it comes to a stop? So you're working out braking distance here. Try and ignore this bit, that shouldn't be here. I meant to do some animations for this, and that must be one I missed out. So to work out the distance, that's the equation we're using. So kinetic energy, half times mass times speed squared, equals force times distance, the work done. So that's our equation. We then take our numbers and we substitute them in. So we've got half times mass must be in kilograms, that's in kilograms, that's good, times by speed squared, speed's in meters per second, that's what we want it to be, that's good for us. So half times 1,500 times 10 squared equals the force in newtons, 10,000, times by the distance. We then rearrange the equation, that's already here, that's what I wanted to kind of appear in an animation. But we're dividing both sides by 10,000. So that 10,000 there is coming down to this side. And we've got half times 1,500 times 10 squared, all divided by 10,000. And then we work out the answer. Oh, that was the animation. And then there's the answer. So that we just get by putting those numbers into the calculator. So it'd be half times 1,500 times 100, which is the 10 squared, equals, and then divide that number by 10,000. That gives us a stopping distance, I shouldn't really say stopping distance, a braking distance of 7.5 meters. Any questions you have when you're going through some of this working from home stuff, going through those booklets and the various bits of work that have gone up, please email or post in the classroom, and we can start doing more things like this and going through various bits and pieces. Okay.